Hello and welcome to everybody. Welcome to our Essentials 40S class. Today what we're going to do is we're going to talk about lesson 2, which is a regular polygon. This is going to be the last lesson of the booklet and the last lesson for the course. So I'm sure all of you are really excited about this last lesson of the year. So um, so congratulations to all of you who stayed and continued to participate. So that's great. I'm so proud of you. So anyways, today what we're going to do is we're going to talk about regular polygon. So what is a regular polygon? Let's break down the words in here. So it says here, a regular polygon is an enclosed shape with some number of sides that are all the same length. So this is a key word, all the same length. That's what makes it regular polygon because they're all the same length. So shown below are some polygons with their names and the number of sides they identified with. So, so regular polygon means poly means many, okay? Regular means all the sides are equal. So these are the regular polygons and their names. So we'll start with this one in here. So this is called a three-sided polygon. So here, number of sides is three-sided polygon. And all three sides are equal. So if I can go like this, the three sides are equal. And when we looked at the trigonometry, we actually called it an equilateral triangle. Okay, so we don't say a three-sided polygon for a triangle like this, an equilateral triangle. We just call it equilateral triangle. Okay, so that's one. And then the next one is called a four-sided regular polygon. And we don't say it four-sided regular polygon. We just say square. And let's take a look at this one here. Now from here, we don't have we do have specific names for these things. So a five-sided polygon, it means all five of these sides are equal. That means all the same length. And it's called a pentagon. A six-sided polygon, regular polygon, is called a hexagon. Seven-sided is called a heptagon. This one here is eight-sided polygon is called an octagon, and this is what it looks like. So there should be 8 sides to this. So let's go 1, 2, 3, 4, 5, 6, 7, 8. Okay, and then it can keep going and going. So this one here is a 9-sided polygon. It's called a nonagon. A 10-sided polygon is called decagon, and then hendecagon, dodecagon. So I mean, you certainly don't have to memorize the names, but if you remember some of the names like pentagon, hexagon, or octagon, so that's great. Otherwise, you could always go back to the notes and take a look at the names and how many sides it has. So let's take a look. So as a number of the sides increases, so if we continue to put more sides, the regular polygons get wider and wider. For example, a regular polygon with 100,000 sides, okay, is decimiragon. I can't even pronounce it. So you do not need to memorize all of these names. So just like I said, we will normally be provided with the names and the number of sides. So if you have the name, you can figure out the number of sides. If you have the number of sides, then you can figure out the name. So it's, like you can always refer back to this. So in this particular lesson, we're going to talk about central angle. What does that mean? Okay. So you're already kind of thinking, but based on the name, central angle. So it has something to do with the center. Interior angle, so you're already telling you interior means inside the angle, and it's a sum of the interior angles. interior angle, again, it's one interior angle. How big is that? Exterior angle. Exterior means the outside angle, so we'll talk about that. Diagonals, how many diagonals, how many lines of symmetry, and the number of sides. So, and the formulas are going to be given to us. It's on our, oh, didn't prepare this ahead of time. Oh, there it is. It's in this formula sheet that you have. Okay, so if you have it, then that's great. It's on the book, so it doesn't really matter. So some of the formulas that we are going to be using are right here, right there. Okay, so we'll talk about that, and all those, like I said, all those formula are in the booklet. So let's start with we're going to just talk about the examples. And for this one, we're just going to just use Pentagon. Okay. So to explore the concepts laid out, okay, so we're going to talk about central angle, all that stuff. We're just going to use the pentagon shape. So five-sided regular shape. So I'll start with central angle. Central angle. What is a central angle? So as you can see, the word center, when you have this shape, if you draw a line segment from each vertex of a regular polygon to its center, you generate what they call central angle. So if you're starting with okay, you don't have to draw this, but I just wanted to show it to you. So if you're given this shape, for example, you approximate the center. Okay, my center is right there. Okay, and if we draw from the center to the vertex, vertex is the corner points, and then center to the vertex, center to the vertex. We already created central angles. So central angles is basically an angle from the center right there. Okay, so one of them. So let's take a look at this one. How do we know how big is the central angle? And this is what it is. So this is something that we know. If we go all the way around, that is one run around turn is 360. So 360. So because it's 360, and then we're breaking it up into this many angles. And the number of angles actually depends on the number of sides. So it's going to be 360, right? Because it's the whole angle in here at the center is 360. And then if we divide it into portions right there, like from the center to the vertex, from the center to the vertex, we're going to end up with the number of sides is the same thing as the number of central angles. So 5 central angles. So in this particular case, let's calculate the central angle. Central angle is equals to 360. Okay, remember, we're just going to use the pentagon divided by n, where n is the number of sides, because the number of sides tells us the number of central angles. That's going to be 5. So 360 divided by 5, 360 divided by 5 is going to be 72 degrees. Okay, so I just want to write down in here, this is the formula, and then can you see here, this is C, so it talks about central angle formula. Okay, so C talks about central angle. That's a central angle formula. And then I'm just going to add more things to it. So where n is the number of sides, which is also the same thing, which is also the same number of central angles. Okay, so that's that. I just wanted to add that piece. Here's a formula. Put a star beside it so I know it's okay. So that means, okay, so we've calculated the central angle. I'm just going to write down where the central angle is. So this is going to be central angle, 72 degrees there, and then 72 degrees there, 72, 72, and 72. Okay, so 72 degrees is each one of these, okay, at the center. Okay, so we've calculated it and we've labeled them. Okay, now let's take a look at the sum of interior angles. So let's break down the words here. The word sum means all of it together, all together, added together, right? So sum means all together. Interior means inside, inside angles. So if we wanted to figure out an interior angle of a regular polygon by two adjacent sides of the polygon, that's basically the interior angle. So interior angle, so if this is a regular polygon, okay, interior means inside. So the angle inside. Where's the angle inside? It's right here. So these are the interior angles. These are interior angles because they're inside the polygon. So how do we figure out the sum of interior angles? Okay, well, there's a formula for that. So here's, can you see the word sum? Sum, there's the S, sum. So S is the sum of the interior angles is equal to 180, okay, 180 degrees, and then brackets means times, n minus 2, close brackets. What does the n represent again? So n is representing the number of sides, the number of sides. So how can we, okay, for this example, this is the example. Calculate the sum of all interior angles of a polygon. So that means we're not just going to find just one interior angle. With this formula, we're going to find all of the interior angles combined. So all of these interior angles combined, that's a sum. So S is equal to 180. I'm following the formula. Times, so I'm going to put a brackets, and because we're talking about pentagon has 5 numbers of sides, so n is equals to 5 sides. Okay, so 5 sides, I'm going to put 5 right there, minus 2. Okay, so sum S is equals to 180 times 5 minus 2. So I'm going to go 180 times 3. 180 times 3. So what is that equal to? I don't know. Let's take a look. 180 times 3 is equals to 540 degrees. Okay, so the sum of all the interior angles adds up to 540. So this is for all interior angles combined together. Okay, all of them. Okay, that's why it's so big, because it's all of them. Okay, so that's that. Okay, now let's move on. Let's move on to the next piece. Okay, I hope you had time to write that down. If you didn't get all of it, then that's okay. Just we'll move along, and then I will post them on the blog today, right after our class, right after our live stream. So this one is slightly different. Okay. It says here, now, the one previous is called the sum of all interior. Well, how much is one, or how big is just one interior angle? So if we know the sum of all interior angles, which we calculated, okay, using a formula, in a regular polygon, finding the size of one of interior angles is relatively straightforward. Just divide the sum of all interior angles by the number of interior angles, and the equal number of interior angles, there's an equal number of interior angles to the side of any regular polygon. So you could use this formula as a shortcut. So this one here is for all interior angles, which is pretty much here, sum of all interior angles. And then if we divide it by how many interior angles, which is basically the same as the number of sides. Okay, so let me do that. Okay. So we've already figured this part out. We can just divide it by n, the number of angles. So let's try to do that in here. Okay, so try that again in here. So to find just one interior angle, and then again, we're going to use pentagon. So pentagon means n is equals to 5. That means there are 5 sides. So let's try that. Sum interior angle. I'm just going to put INT. Okay, shorthand for interior angle. And if we use the formula here, 180 times n minus 2 divided by n. Okay, so we're going to put the values in our formula. So this is going to be, you know what, I don't like that. I'm going to fix this so that it's okay. 180 times n minus 2. So what is n again? N is 5 because we're talking about pentagon. A pentagon has 5 sides. So we're going to put 5 there, minus 2, minus 2, and then follow the formula, follow the recipe. So now we're going to divide by n. So divided by n. N is 5 again. Okay, so here's a tricky part. Here's a tricky part because I know we could, follow the formula here. We're going to put the values in the formula. Now it's a matter of typing it in. So we want to tell the calculator how to type this in. A better way to do this is to follow the orders of operation. So here's what we can do. 180, okay, 180 times, and then 5 minus 2, that's 3 divided by 5. 180 times 3 divided by 5. So now we can just take our calculator. Oh, you know what? I think we could do it all at once. 180 times 3 divided by 5 is 108 degrees. 108 degrees. And then this one here is just for one interior angle. One interior angle. So what does that mean? What does that mean? Sorry, I had to grab my other color pen, so I have different things in here. So this is one interior angle, so that means this is going to be 108 right there, degrees, of course. And then this is 108 degrees, and this is interior because that's inside the shape. This is going to be 108, and then this part is going to be 108, and then this part is going to be 108. Okay. So in this particular case, one of the 5 interior angles, so if you just focus on just the one, it's going to be 108 degrees. Okay, just focusing on one. Okay, is that good? Okay, so they repeated this again. So each interior angle measures 108 degrees, and then there's a picture here, which we already did up above. Okay, so to do this, we have to first, just gonna move it up a bit. So note, if we want an interior angle, so we first figure out the sum of all interior and then calculate the individual angles. So this is the formula for that. Okay, so there's a formula for that one right up here. So when they say interior angles, you use this formula. Okay. I find that this is really not a tricky topic because they tell you exactly what you needed, and then you get it from there. Okay, so the next one, okay, let's read that. The size of exterior angle. Okay, size of exterior angle. So what does exterior mean? Exterior means outside. The outside, okay, outside angle. So what is an exterior angle? So let's read on. For any regular polygon, an exterior angle is formed in the space between the extension of one side with the adjacent side. The pentagon has two exterior angles labeled. So exterior angle is the angle inside. So this is your interior angle. interior, I just put again INT angle like that. Exterior is like if I extend this arm this way, so it's straight, that one, and then this angle is going to be the exterior. Okay, so exterior is not the whole angle around, it's just if we extend this arm, this is your exterior angle. So let's see how can we figure this out. We what we can have is, we'll find, this is really interesting, is that, okay, we can look at it in two different ways. We can look at the fact that, hey, this is a straight line. This is a straight line. So I could, and then the straight line forms a 180 degree, so supplementary angles. So if you want, you can figure out the interior. If you know the interior angle, you can figure this out. But here's one interesting property for a regular polygon. It says here, this is an interesting because you don't have to know the interior to do it. So one interesting property of a regular polygon is the fact that all exterior angles have the same size as a central angle. Isn't that amazing? So the angle, okay, the exterior angle is the central angle. So how do we figure out the exterior angle? Same thing as the central angle, right? So it's 360 divided by n. So 360 divided by n. So in this particular case, so here's an example. Calculate the size of exterior angle in a pentagon. So we're always using pentagon as our example. So pentagon, okay, it has n number of sides. N is 5, okay. So if we were to figure out the exterior angle, so therefore exterior, I just put EXT angle is equals to 360 divided by n. Okay, so what is n again? N is 5 because pentagon has 5 sides. So it's 360 divided by 5. Okay, I forgot what that is. 72. 72 degrees. 72 degrees. Which really makes sense because what did we say here? We said an interior angle is 108. This is 108. And then how much more do you need to go here to make it 180? So if I take 180, subtract 108, that is 72. So this is 72 degrees. So 72 degrees. How many exterior angles do we have? We're going to have, there's one here, and then there's one there, right? So 72 degrees. Okay, that's awesome. So put a star beside it because that's a formula. Okay. Now I'll leave it up there like that. Okay, now the next thing that we're going to do is we're going to talk about number of diagonals. Okay, what is the diagonal again? So diagonal is when we create a line segment from one vertex to the other. Okay, so a diagonal of a regular polygon is a line that connects a vertex to another vertex, but it has to be a non-adjacent means the word adjacent means beside. Okay, so non-adjacent, so none one after the other. So if this is my vertex, if this is my vertex right there, I can't, and then I draw it to this side, this vertex, that's not a diagonal, that's a side. Okay, so you want a diagonal which is non-adjacent, not beside this vertex. So the diagonal is from here to there. So I'm just going to use a ruler if you can. So grab like some kind of a ruler or straight edge. So this is a diagonal, one diagonal. Okay, so if this is our starting point, now what's the other? Can I create another diagonal? Yes, I could. So I can go from here to this vertex, from here to this vertex. Okay, so let's do that. Okay, so far that's that. Okay, and then is there another diagonal that I could draw? So this is okay, so if I see that another person just joined, so if you're just joining us, we're on page 11. Okay, page 11. We're just doing this number of diagonals. So here, so we started off with this vertex. I can't connect it to that one because that is not a diagonal, that's a side. So from here to here, well, that one is a diagonal. And then from here to here, that's another diagonal. And can I go from here to here? And the answer is no, because this is not a diagonal. This is just the side of the polygon. Okay, so this vertex can only be connected to two. Okay, so what else? Now let's go to this vertex. This vertex. Well, this vertex, the one that I can connect to is not on this one, but this one. Like that. So from here to there. And then I go here. Okay, well, where's the other place I could go to? I can take from this vertex to this vertex. And that is a diagonal. Diagonal right there. Okay, so far we did this part and we did this part. Now let's go to this vertex. Okay, so where can I connect this vertex? I cannot connect it to this one, okay, because that's a side. Where can I connect it to? To this one. So that, okay, and then the next one would be I can connect this to that one, but it's already done. Okay, so it's already done, so I'm done. So I go to this one. Where can I connect it to? The vertex would be from here to there. Okay, but I've already done the diagonal from this vertex to this vertex is the same thing as the other way around if we go from the other direction. And then the same thing with this one. Okay, so this is one vertex and then that it's connecting to, and then this is another diagonal to connect to that vertex. So we've created this shape, which is, well, the question is, well, how many is that? Well, it's easy to keep track of it when we don't have a lot of diagonals, so it's easy. But what we can do is we can calculate. So how do we calculate? Okay. So because they're asking for the number of diagonals, so that's why it's called D, diagonals of any regular polygon, so we can use this formula. So D is the number of diagonals equal to n times, times, so brackets, n minus 3, close bracket, and then divided by 2. Okay, so let's see. Let's calculate it. So this is the example that we're going to do. And then the example, we're always using pentagon in all of our examples. So calculate the number of diagonals in a pentagon. So a pentagon has n number of sides equal to 5. So n has 5 sides. So how can we figure out the diagonal? So diagonal is equals to n times n minus 3 divided by 2. Okay, so what's n? N is 5, so we're going to put 5 in this place times 5 minus 3 divided by 2. Okay, so let's do that. So D is equals to, and we could certainly do this all at once. Let's see here. So 5 times 5 minus 3, close bracket, divided by 2, it's going to be 5. So there are going to be 5 diagonals in this particular case. Okay, so 5 diagonals, and we've drawn them over here. Okay, so that's good. If you have any questions, certainly send me an email, or if you would rather, let's say if you can't explain your question via email, so just you can tell me, oh, can we do a Google Meet, and then we could do that as well. Okay, so yeah, you can ask questions that way. Okay, so we're on page 12. Page 12. This one is called So we're on page 12. It says, find the number and draw the lines of symmetry. Okay, what are the lines of symmetry? Lines of symmetry is a line that splits the polygon exactly in half so that there is an identical but opposite shapes on either side of the line of symmetry. So it's like cutting the shape in half, and then there are like a mirror image on each side. So below is a diagram showing a pentagon with one line of symmetry. Can we draw other lines of symmetry? So here, this is one line of symmetry. If this is the pentagon, I can draw a line there and see it's 2 equal halves. Okay, what's the other way I could do this? Okay, well, the other way of doing this is normally I like to turn it around. So if I turn it this way, I can see that, hey, this is my other line of symmetry. Okay, so I'm just gonna eyeball it. This is the line of symmetry, so that if I cut it this way, can you see the green line here? It cuts this pentagon into two equal halves, right? Two equal parts. Okay, now I'll go over here. Like I can turn it this way. You don't have to turn it, but I guess I like to turn it the other way. So it's always right side up for me. So here's the other line of symmetry. I'm going to actually color it a different color. I'm going to do a blue. Okay, this is my other line of symmetry. Okay, they should be meeting at the center here. Okay, and then what else can I do? Okay, I can turn it this way. I can do another line of symmetry there. I'm going to do a different color. Okay, so do I have all of them? Not quite yet, because I can still see this part here. Let's see. Do I have any other different color? Hold on. Okay, let's see if this is gonna work. It's like some kind of a purple. Here's the other line of symmetry. Right there. Okay, so we have how many lines of symmetry? Lines of symmetry cuts the figure into two equal parts. Okay, exactly half. So we have one, this black line right there, and then number two would be this red line right there. Number three is this green line right there. Number four is this purple line right there. And then number five, this one should be the blue line right there. So there are 5 lines of symmetry. And then I can't count 6 anymore because it's the same line as number 1. Okay, so what have we noticed? Notice that when you are done, you have the same number of lines as the number of sides in a polygon. Okay, so that means lines of symmetry. Lines of symmetry, is that even enough? No. Number, write down a formula here because we like formula. The number of lines of symmetry equals n, the number of sides. So if there are 5 sides, then there are going to be 5 lines of symmetry. If there are 6 sides, then there are going to be 6 lines of symmetry, and so on. Okay, now we're on the last bit here. So this is the absolutely easiest question of all. Now backwards question. Okay, so backwards question is something that we can either do a guess and check, or we can use algebra skills to do this. So sometimes you will be asked to find the number of sides. Okay, so we can either use, like I said, algebra or guess and check. Okay, so here it is. Determine the number of sides of a regular polygon that has a central angle measuring 45 degrees. Okay, so let's do this one here. I'm going to just show you the algebra part, but then if you're not comfortable with that, then then we could yeah, do guess and checks. So Determine the number of sides of a regular polygon that has central angle measuring 45. Okay, well, what do we know about central angle? Central angle is equals to 360 divided by n, where n is the number of sides. Okay. And then why did I take this formula compared to other formula? Because they're giving us central angles. Okay. So they're telling us this clue that the central angle is 45 degrees. So here we go. Central angle is equals to 360 divided by n. Central angle is 45 degrees here, is equals to 360 divided by n. So this is where, if you want, you can guess and check. Okay, so I'm gonna try to show you how to guess and check in here. Okay, so what if it's 3? So I can go 360 divided by 3. I got 120. Okay, that's not 45, so that's good. So I'm gonna try 360 divided by 4. Nope, that's not good, not enough, right? What about 360 divided by 5? Oh, getting closer. Okay, 72. What about 360 divided by, let's by 6? Oh, no, 60 degrees. So 360 divided by 7. Oh, did I just say 360 divided by 7? No, 51 point, no. 360 divided by 8, 45. Okay, so if you want, you could do a guess and check. So you can say therefore n is 45. But if you don't like that, you have guess and check. You could do the algebra method. So how do you do that? So 45 equals to 360 over n. So what are we going to do? We know how to do this. We're going to cross multiply. So I'm going to cross multiply. So cross multiply there. And if there's nothing in the denominator, it's understood it's 1. So if we cross multiply, it would become 45 times n. 45 times n equals to 360. Now what we're gonna do is we're gonna have the n alone. So 45 times n. So the opposite of multiplying, which is dividing. So we're gonna divide by 45. Divide by 45. So 45s will cancel. Okay, so 45s will cancel. And then we're left with n is equals to 360 divided by 45. It's going to be 8. So 8 sides. Okay, so that's, like I said, we could do guess and check, and then we'll go on from there. Or you can do the algebra method, whichever you prefer. Okay, so let's do another question. Determine the number of sides. Okay, so determine the number of sides of a regular polygon where the sum of interior polygon is 720. Okay, so sum of interior angles. So how, because they're giving us this clue, the sum of interior angles, what is the formula for sum of interior angles? Is S is equal to 180 times n minus 2, right? So, and sum of the interior. Okay, so what do we have in here? They said the sum of interior angle is 720. So sum is 720. So that means S is 720. Okay. So how do we do this one? How do we do this one? Well, we could do guess and check, okay? We can guess and check. So we can say, okay, I'm gonna I'm gonna guess 3. Okay, so 180 times 3 minus 2. Okay, I'm gonna guess 3 sides. I'm gonna get, oh, it's only 180. Okay, so that's not the one. I need 720. Okay, so I'm gonna guess 4. 180 times, okay, what if it's a 4-sided? So 4 minus 2, that's 360 times 5 minus 2. 5 minus 2, what does that equal to? 540. Okay, not enough. Okay, I'm gonna try 8. Okay, 180 times 8 minus 2. Oh, that's too much. That's too much. What about 180 times 7 minus 2? 900. Okay. So I lost track of what I did 8, 7, 6. 180 times 6 minus 2. Can't even remember if I did that already. Oh, there you go. So n, I tried a whole bunch of values for n, number of sides. And then what worked is, did I say 6? So n is equals to 6. And that's by trial and error. Okay, so just to kind of verify again. 180 times 6 minus 2. Yes, 6. So that's a possibility, okay? This is by trial and error. Now, what if we wanted to do this using algebra? Okay, well, what can we do? This is the algebra method. I know it's 720 equals to 180 times n minus 2. Okay, so what can we do? What we're going to have to do is to have the n isolated, n by itself. But look at this one here. 180 is being multiplied by all of these. So what we can do is we can do the opposite of multiplying, which is dividing. So to cancel that 180, I'm going to divide by 180 on this side. I'm going to divide by 180 on this side. Okay, so that becomes 720. Oops, you can't see that. 20 divided by 180 equals, I got 4. So I got 4. 4 is equals to n minus 2. Okay, now you look at this. Something that I have to subtract 2 will give me 4. Okay, so that tells me I can think about, like, I gotta add 2 on each side, 2 on each side, then I get 6. So n is equals to 6. Okay, so something, what is that number when I had to take away 2 will give me 4. So that's 6. The method. Okay, so trial and error method, algebra method, whichever you prefer, doesn't really matter. Okay, last example as far as I know. This is another backwards question. What did they say? Determine the number of sides of a regular polygon that contains 35 diagonals. 35 diagonals, okay. 35 diagonals. Oh, yes. So what do we know about diagonals? Diagonals is equal to n. Okay, I gotta take my notes here. My formula, n times n minus 3 divided by 2. Okay. So how can we do this part in here? And 35 for diagonals. Okay. Well, they're giving us 35 there. So 35 is equals to n times n minus 3 divided by 2. So we could do a trial and error. Okay. So there are 35 diagonals. How can we do this one in here? We could do trial and error. Okay, so let's pick a number. Okay, let's pick a number. I'm gonna pick 6. I'm gonna pick 6. Okay, so if I pick 6, I'm gonna put 6 here for this space, and then 6 inside here. So I'm gonna go. Okay, how do I do that? 6 times. I think most of you have brackets, so you can go times brackets or just brackets, depending on your calendar. 6 minus 3, close brackets, divided by 2. Okay, that's only 9. Okay, we need 35. Okay, so I tried 6. It doesn't work. Okay, I'm just going to keep track of what I tried. I tried 6. Doesn't work. So I'm going to try 7. Okay, so I'm going to try 7. Go 7 times 7 minus 3, close bracket, and then divide it by 2. 14. Okay, no. So the answer that I got here is 14. Then that's not the one. Okay, so I'm going to try 8. I'm going to try 8. Okay, so 8 times 8 minus 3, close bracket, divided by 2. I got 20. Okay, well, that's not that one. Let's try 9. So I'm going to put 9 in here and 9 right there. So it's going to be 9 times 9 minus 3 divided by 2. Close brackets and divide by 2. 27. So nope, not that one. I'm going to try 11. Okay, I'm going to skip the 10. I'm going to see if 11 works. So 11 times 11 minus 3 divided by 2. 44. Oh, we skipped 10. I went to 11. I got 44. So no, gotta go back there. So now I'm going to try 10. It's funny. Put 10 times 10 minus 3, close brackets, divided by 2. And I get 35. So the answer is 10. Good. Oops. So the answer after all the trial and error is going to be 10. So n is equals to 10 because we tried all of these. It didn't give us an answer of 35. Okay, so by trial and error, these are all the numbers that we tried that are not good. And then we figured out 10. Now, how do we do this in algebra way? Okay, so let's take a look. How do we do this algebraically? So we got 35 equals to n times n minus 3 divided by 2. So what we can do is we can get rid of this 2 in the denominator by cross multiplying there. Cross multiplying. So that becomes 2 times 35, which is 70, equals n times n minus 3. Okay. Now, because in Essentials Math, we don't talk about solving quadratic equations, what we have to do is we can just think about critically thinking a possibility. This is like one number and then another number. What number times another number will give me 70? Okay, so what number times another number minus will give me 70. And the only possibilities there are are um, two numbers. Okay, multiply together will give us 70. So you can say, okay, well, 70 would be 2 times 35. Okay, well, that's not going to work because if I put 35 here and if I put 35 there, minus 3, it's not going to give me 2. If it's 70 is equals to um, 70 divided by, and if we go 70, it would be 10 times 7, and then that would work, right? Because when you go here, if I put 10 in here, and if I put 10 in there, that will give me 10 times 7. Okay, so what other 70? No, that doesn't work. Um, mm, 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 mm. 5 and 14. So if I go 5 and 14. So if I put 14 in here, and if I put 14 there, then it's not going to give 14 there and 14 there. That's not going to give me the right number, right? Because it's so in this particular case, there's something here that we could do to solve this algebraically, but that's more like a pre-calculus class. So in this particular case, I would say use trial and error. Okay, so that's the only thing here. Use trial and error for that. Okay, so there you go. I think we finished everything. We just have to look at the summary. This is on page 13. 13. Okay, let's see here. What's the summary? Summary. Again, this is a summary of all of the formula. So we talk about central angle. See, central C. Okay, central angle. Sum of interior angles. That's why it's S. Sum. Interior angle. So this, if you want to rewrite everything down, then it would be the same thing as the sum of interior angles, which is 180 times n minus 2 divided by n. Okay. Size of exterior angle, which is the same thing as the central angle. Exterior angle, 360 divided by n. Number of diagonals, so diagonals D. Oh, this is the number of lines of symmetry, same as the number of sides. So calculate the well, there's really nothing to calculate because whatever the number of sides is equal to the number of lines of symmetry. The number of lines of symmetry is equals to n, whatever n is. And then calculate the number of sides of a regular polygon given the value or characteristic. So this is more the backwards question. Oh, we're going over time here. Backwards question, and either use trial and error Or if you're comfortable, you can try the algebra method. Okay, so uh, that's it. We are done. I'm so uh, proud that we made it to the end. So just to let you know, we are not going to do the last booklet. I know that the last booklet is the precision measurement. This is the stopping point. This is the end of it. Now you're probably thinking, oh my gosh, we're done. Um, I'm thinking of having a test, okay? Having a test on Friday. So I'll put it on the blog just like normal. So if yeah, I'll put the test up. I might even put the test up on a Thursday. Oh, is today Wednesday? Yes, it is. I might put the test up on uh, Thursday or Friday, and if you know like done all of these practice questions, you could start doing them. So you know what? I'm gonna make a decision. I'm gonna make a decision. I'm gonna post the test on Friday. Okay. Now, don't panic. Um, okay, don't get stressed out. I'll post it on Friday. Um, and then the very last day of classes is actually um, June 12th. So if you can't write it on Friday, write it on Monday. So that's, you have the whole weekend to work on your catching up. So test. I'll post it on test on Friday, and then you can also have time on Monday. Okay, everybody, I just want to say thank you very much for taking the time and participating at our lesson. Um, if there's any questions, just send me an email. I already said this earlier, and I think I might have said it before. If you can't, just explain your question from the email. You can tell me, like, can we do a Google Meet, right? And then we can certainly make a time to do a Google Meet together. And you can ask me a question. I can work it out with you. So, yeah, that's a possibility. Okay, I hope everybody is well and staying healthy. I'm glad that you are still here and you're still working along. I think I'm gonna stop it here for now, and I wish you a great day. And you can work on the questions that are on the booklet, assignment number 2. Okay, so there you go. Have a great day, everybody, and I'll talk to you soon. Okay, bye for now.